A toy is made up of cylindrical rings stacked on a base as shown in the diagram. The diameter ring is ring 1 is 87% of the diameter of the base. For ring 2 through ring 7, the diameter of each ring is 87% of the diameter of the ring directly below it. The diameter of the base is 5 inches. Which function is used to find the diameter in inches of ring R, where 1 is less than or equal to R is less than or equal to 7. So whenever we're doing this, all of these are set up to be every time we're doing 87% of the previous diameter, so that's going to be exponential. And we're going to figure out where we're starting. The starting is right here, 5. So our function is our AB to the x. So where are we starting every time? 5. So you can eliminate 2 of these choices just by knowing that your 5 comes first. Okay. And then we have to decide what we're doing next. So this b value is what you're multiplying by. And that's what's happening right here. Now what's different about this 87% is normally we do 1 plus or 1 minus that percent because that's just your rate. This one, 87, when it says of the diameter, that's saying multiply. So multiply by 87%. You're not doing a percent growth or percent decay. This is what you're multiplying by. But you can't, again, multiply by a percent. So you do Dr. Pepper on that. You take your decimal 2 to the left, and that's just dividing by 100. That's what's happening when you convert. You're either multiplying or dividing by 100. So we're going to multiply by 0.87, and that's this one right here. Then your R is the number of rings. That's the number of layers, the number of times that you're multiplying by that 87%. And so that's why this R is up here. We're not going to choose this one because this R right here doesn't make sense. If you got confused about that 1 plus or minus your R value when it was giving you your percent of increase or decrease, this would not be correct. So there's no 1 involved, so that one can't be correct anyway. The answer is F. For question 50 over here on the side, the number of stores opened by a coffee company can be modeled by the exponential function graphed on the grid, where x is the number of years since 1992. Based on the graph, which statement does not appear to be true? That's very important. The coffee company had opened 400 stores by the end of 92. So 92 is right here. So is this 400 stores? Yes, this is true. I want the one that is not true. So that one's not going to be our answer. The coffee company opened 100 stores in 1 year. So if we go over 1, is that going to be 100 stores? Well, right in between 400 and 600 would be 500. From 400 to 500 is 100 stores. So this one would also be true. Every year, the number of stores in the coffee company open increased by 25%. We would have to do a little bit of work for that one, so I'm going to skip that one for now, and that's a good test-taking strategy. Since 1992, the coffee company has opened 250 stores each year. So if we look, opening the same number of stores each year is not going to be exponential. That would be linear. You're adding the same number each time. So that's not going to be correct. And we also know that because this first year we didn't add 250, we added 100. So that's going to be false. So J is our answer because we want the one that is not true. Now just to show you this one, H, how to verify that indeed you did get the correct answer. Again, this one takes a little bit more work. So what I did is I found a couple good points that I could put in. This 400, 0, 400 was pretty good. This point over here, 5, about 1,200. And then over here, this one was also pretty good, 8, 2,400. And this is going to be pretty close to an approximation. It's going to be pretty close. And I asked Desmos to find the equation for me. And so that's what it did. And again, this isn't going to come out exact because I didn't use exact numbers, but I got it pretty close. So my A value, my beginning value, is going to be close to that 400. And then over here, this says 1.25, and then there's more numbers, but I wanted to remind you that our R value, 1 plus your R, so that's 1 plus 0.25. And if I wanted to know what percent that was, I would do Dr. Pepper on it. And I would change that decimal to a percent by moving to the right this time, 2, and that would be about 25%. So by just kind of using some numbers that are pretty close, I can ask Desmos to come up with that equation for me, and I can check it that way, and that is about that 25%. So this one is true also. And then the last question, number 40. The table contains some points on the graph of an exponential function based on the table. Which function represents the same relationship? All of these are talking about AB to the x. So A is where we start. That's our y-intercept, and your y-intercept is going to be right here. Right? Because when we graph it, we go sideways. X is your sideways number. Y is your vertical number. So going horizontal, sideways 0, that means don't go sideways at all, and then you go up to this number. So that's right here. So it looks like that is automatically going to be my answer, but let's double check this 4. This 4 right here is your multiplier. It's called your factor. If you don't like these up here with your decimals, that's fine. You can check this one first. 1 times 4, is that 4? Yes. And then you can come over here and you can tap a new line, and you can ask Desmos to do this for you. 0.0625 times 4, and that gives you this 0.25. And if we do tap a new line, we're going to do 25 hundredths, which is 0.25 times 4. That's where we get our 1. And yeah, that makes sense. That's a quarter. If you have 4 quarters, you have a whole, you have $1. So that's that math without the calculator. So we did check that, and this one is also correct. So H is our final answer. If you wanted to make sure a different way, you could ask Desmos to do the equation for you. You could type in 0.0625. Then we had 1. And then that was 0.25. And we had 2, 1, and then we have 3, 4. I just edited a table that I already had, but if you don't like that, you can add a new table. Just make sure your table is talking about x1 and y1, so that when you ask Desmos with y1 worm, your y1 matches the 1 from your table. And I did all that and I didn't show you there. So x1 and y1 match x1 and y1 right here. And then we can double check your A value is here, your B value is here, and that's how you would do it using Desmos. You would use y1 worm, A, B to the x1.